In lesson 12, we're going to be going from ratio tables to double number line diagrams. The directions ask us to solve each one of these problems using a double number line diagram. So this is just another way to organize information to help us solve a problem. You can use ratio tables, but you can also use double number line diagrams. So example 1 says Sylvia makes $18 for every 2 hours of babysitting. How much money will she make in 9 hours of babysitting? So the first thing to notice is we have this double number line set up. You'll notice that it starts right here with the line going down. This is typically where your 0 point is going to be for each number line. Now, each number line should be labeled with the 2 units from the problem. So we're looking at how much money she'll make, and then we're looking at hours. So depending upon how you want to set this up, it doesn't matter which one goes where. I'm going to put the money on the top, and I'm going to put the hours on the bottom. Okay, so they're lined up. Typically, what I would say to do is to make sure that you are including the numbers from the problem. So looking here, I know I have 2 hours that should be on here, and I'm also trying to figure out how much 9 hours would be. So what I'm looking for should be at least the last thing on my number line. So I'm going to number from 1 to 9 on the hours line. So I'm going to draw a line between each, making that 1 hour, 2 hours. Notice it goes straight through because it's going to show the connection. Okay, so in the problem, they're telling us that she makes $18 for every 2 hours. So across from the 2 hours, I'm going to put 18. So it's kind of like a ratio table turned on its side. So what I'm going to do is figure out how much it is for 1 hour and work from there. So what I'm going to do is 18 divided by 2, which gives me 9. So that tells me to go from my number of hours to my money, I'm doing times 9. Okay, and you can write that somewhere on your number line to show 2 times 9 is 18. So that means at 1 hour, I would also be doing times 9. So 1 times 9 is 9. 3 times 9 is 27. And something you may notice as you're moving along the bottom, you're counting across by ones. And across the top, we're now counting by 9. So 9, 18, 27. So you can either continue counting by 9s, or you can continue with the multiplication of 9. So 4 times 9 is 36. 5 times 9 is 45. 6 times 9 is 54. 7 times 9 is 63. 8 times 9 is 72. And then 9 times 9 is 81. So that shows us in 9 hours, because again, this is our hours bar, or line, excuse me, we're making $81. So the answer would be $81. Notice in a double number line diagram, we're scaling down to 1, and then we're scaling back up to the 9. Okay, in our next example, Jane makes $4.50 an hour at work. She wants to save $29.25 for a trip. How many hours would she need to work to save that much money? So now in this case, they're telling us how much she makes for 1 hour. So again, I'm going to do my money, and I'm going to do my hours. I'm starting at 0, 0. She's making $4.50 for 1 hour. We're trying to work our way up to $29.25. So what I'm going to do is I'm just going to start going from my $2. To get from 1 to 450, I multiplied by 450. So that means I'll continuously do that. So from 2 times 450 gives me 9. 3 hours, that's still not what I'm looking for. I'm looking for that $29.50 times 450 would be $13.50. 4 whoops, times 450 is going to be 17. Let me make sure, actually, I'm going to check that. I think my math is off. It is. It's 18, not 17. Excuse me. Okay, 18 is still not where I need to be. For 5 hours, I would do times 450, which is 2250. Again, still not where I need to be. For 6, it would give me 27. For 7, doing some side math here to help me figure this out. I'm adding, because I'm adding across the top, but I could also be multiplying. I get 3150. So now, what I'm noticing is my 2950 is falling somewhere between 6 hours and 7 hours. So I know that I'm multiplying by 450. So something that you can do here is you can work kind of in between here. So halfway between 6 and 7 is 6.5 hours or 6.5 hours. So maybe I can multiply that by the 450, and I'm actually going to take out my math tools here, calculator. So I'm going to do 6.5 hours times the $4.50 and see that that is where it would fall. So it's actually going to fall between two numbers. So 6.5 hours or 6.5 hours would give me that 29.25 that I'm looking for. So answers may not fall directly as a number that you have. It may fall in between. So you kind of have to work in between your two numbers. Move this over here. Okay. For example 3, it says for every 4 liters of soda, there are 150 grams of sugar. How many grams of sugar are in 11 liters of soda? So this time I'm not looking at money and hours, I'm looking at liters and grams. Okay, so again we start at 0, 0. Notice I've labeled, I've got 4 liters is 150 grams. So I'm going to break this down and bring it down to 1 liter. In order to do that, I'm going to do 150 divided by 4, which tells me it's 37.5 grams for each liter. So I can do 2, 3, I'm kind of squished here. But to get from each one, I'm multiplying by 37.5 times 37.5 times 37.5. They're all multiplied by 37.5. So I can take my 37.5, multiply it by 2, and get 75. I can take my 37.5 and multiply it by 3, which is 112.5. I'm going to start spacing just a little bit more to have some space. I need to go up to 11 liters. Okay, so each time I'm multiplying by 37.5. So I'm going to go ahead and fill those in. I'm going to be multiplying by 37.5 to each of the number of liters. Okay, so I've done my multiplication all the way up to 11. And now I'm going to do 37.5 times 11 to get my answer of 412.5 or and a half grams of sugar. So that would be my answer for how many grams of sugar are in 11 liters. So again, you're just making sure that you scale down to 1, so how much it is for 1, and then scale back up to how much it is you're looking for. And this is just another way to organize your information to get your answer.